What if I told you that there are invisible warriors within us, constantly battling invaders that threaten our health? These warriors are called bacteriophages. Imagine them as microscopic bodyguards, tirelessly working to keep us safe. Originating from the Greek words bacterian, meaning bacteria, and phagin, which means to devour, bacteriophages literally translate to bacteria eaters. And that's precisely what they do. They are viruses that infect and replicate within bacteria, helping maintain our health by controlling bacterial populations. In essence, they are our allies in the microscopic world, our silent protectors. A fascinating aspect of bacteriophages is their ability to infect bacteria, hijack their machinery, and replicate within them. This process, while complex, is absolutely critical to their role as guardians of our health. Intrigued about these microscopic bodyguards? Well, buckle up as we dive deeper into their world. Our journey begins when a bacteriophage, in its quest for survival, encounters a bacteria. This is not just a random meeting, it's a calculated encounter. The bacteriophage, a virus that preys on bacteria, has a remarkable ability to recognize its host. It's almost as if our bacteriophage has a sixth sense. It uses its tail fibers, like a cat's whiskers, to feel out the bacterial surface. These tail fibers are not just sensory organs, they are also molecular keys. Each bacteriophage tail fiber is specifically designed to recognize and latch onto certain receptors on the bacterial surface. This interaction is like a lock and key mechanism where the bacteriophage's tail fibers fit perfectly into the bacteria's surface receptors. This is no mere chance, it's a coevolution that has been refined over billions of years. Now you may wonder, what happens after this fateful encounter? The real action is just about to start. With the bacteriophage successfully latched onto its target, the invasion begins. Now imagine the bacteriophage as a microscopic syringe. It pierces the bacterial cell wall with its tail, which acts like a needle. Through this needle, the bacteriophage injects its genetic material, DNA or RNA, into the bacteria. This genetic material carries the blueprint for making more bacteriophages. Once inside, the bacteriophage's genetic material is free to embark on one of two life paths, the lytic cycle or the lysogenic cycle. In the lytic cycle, the bacteriophage's genetic material takes immediate control of the bacterial cell's machinery. It hijacks the cell and forces it to produce more bacteriophages. The cell becomes a bustling virus factory, churning out new bacteriophages until it can no longer contain them. Eventually, the cell bursts open, releasing a horde of new bacteriophages ready to infect more bacterial cells. Alternatively, in the lysogenic cycle, the bacteriophage's genetic material integrates into the bacterial DNA. It lies dormant, biding its time. It might remain quiet for many bacterial generations, but when the conditions are right, it wakes up and switches to the lytic cycle, turning the bacteria into a virus factory. Once inside, the bacteriophage's genetic material takes control, turning the bacteria into a virus factory. Now inside the bacteriophage's game of deception begins. This master of subterfuge, the bacteriophage, gets to work immediately. It uses the bacteria's own replication machinery, turning it against itself. This is a classic case of a Trojan horse operation, with the bacteriophage playing the role of the deceitful warrior. The bacteriophage begins by injecting its own genetic material into the bacterium. This could be DNA or RNA, depending on the type of bacteriophage. Once inside, this genetic material starts to hijack the bacterium's cellular machinery. It uses the bacterium's enzymes, nutrients, and energy sources to replicate its own genetic material and create the components of new bacteriophages. While this process is going on, the bacteriophage ensures that the bacterium's own DNA replication is disrupted. This clever virus doesn't want any competition for resources, after all. It's a ruthless strategy, but it's incredibly effective. As the replication process nears its end, the bacteriophage progeny are assembled. New bacteriophages are built from the components created earlier. These new bacteriophages are essentially clones of the original, ready to go out and infect more bacteria. Finally, the bacteriophages are packaged into their protein coats, ready for the next stage in their life cycle. These are the bacteriophage copies, each one a mirror image of the original, each one a potent weapon in the bacteriophage's arsenal. With the bacteriophage copies ready, it's time for them to break free and continue their mission. The final act of this microscopic drama is both devastating and fascinating. The bacteriophage, having replicated itself multiple times within the bacterial cell, now gears up for its grand exit. This exit, however, is not a quiet affair. The bacteriophage triggers a process known as lysis, causing the bacterial cell to burst open and release the newly minted bacteriophages. This catastrophic event for the bacterium is in fact a birth announcement for several new bacteriophages, ready to continue their parents' mission. But what does this mean for us humans? Well, it's a bit of a mixed bag. On the downside, this process can cause bacterial infections to spread rapidly. Yet, on the bright side, bacteriophages have the potential to be used as a form of treatment, specifically in combating antibiotic-resistant bacteria, a growing concern in today's medical world. Thus, the cycle continues, with the bacteriophages relentlessly defending us from bacterial invaders.